Couple more. K absolute value, -3, absolute value, x plus 1. That one looks like this. And, all right, that's a pretty little graph. Okay, talking about domain and range. Need our little line in here, right? We're going to do domain first, so we need this vertical line. Okay, picking up our line, starting somewhere in the middle, and I'm going to go left, and I'm asking myself, how far left can I go before I run out of the graph? Well, if it goes on forever, I will never run out of the graph. So the left farthest point would be -infinity. Okay, now I'm going to the right. I'm moving, asking myself, when am I going to get off the graph? Well, never, because it goes down to -infinity as well. So that makes our domain, I'll run numbers again. So -infinity to +infinity. All right, let's go back to range. This time we're going up and down. So moving it from the middle-ish of the graph. Oh, don't do that to me. Sorry. Okay, taking this graph, I need to ask myself how far down it goes first. It's always the down value first. Goes on forever and ever and ever, so I'm going to end up at -infinity. Okay, let's move it up. Now I'm looking, I'm following the graph, I'm moving up, and I'm asking myself, when is the last time I'm going to see the graph? Right there. And at that value on the x-axis, y is 0. Right, our range then goes down to -infinity and up to 0. Now it is a bracket because that point is part of our graph and it goes through it. Let's see, x-intercept, speaking of that point, is this point right here at -1, 0. And the y-intercept is going to be this point right here, which is at 0, -3. Okay, and behavior. We have to look at two parts of it. We've got a right side and a left side. So on the right side is this one, on the left side is that one. Looks like as x goes this way to the right, so let's say as x goes to the right, which is +infinity, f of x goes to, looks like it's going down, so -infinity. Okay, the left side, now as x goes to -infinity, f of x goes to also -infinity. Even, odd, or neither, if I cut this down that y-axis and tried to match them up, it would not match. If I put a pin in the middle and turn it 180 degrees, it would not match. So this guy is actually neither. All right, choo-choo train, here we go. Increasing or decreasing. Always start at the farthest left point, which according to our domain is -infinity. So here's our little choo-choo. Chugging along, and I say, are we going uphill or downhill? Uphill. So that portion of the graph is increasing. So how far left does it go? -infinity, comma, how far does it go up to here? Well, it goes right there to that x value, which is where it changes course. And that was at -1. Parentheses always for increasing and decreasing. Okay, then looking at the second part of the graph, you can see that once it changes points here, now the choo-choo starts going downhill. So downhill means decreasing, and it starts where the other one left off at -1, all the way to +infinity, because we're talking about over here. Okay, this time it does go from increasing to decreasing. That means we do have an extrema. Looks like right here is our extrema, right? That's a max. And it's at the point -1, 0. So we've got a maximum, -1, 0. All right, transformations. We've got a negative out in front, multiplying by a 3 out in front, and adding 1 inside. So there's 3 changes. That negative outside means there's a reflection, and it's a vertical one, so that means it's over the x-axis. We've also multiplied by a 3 outside. Outside means a vertical, either a stretch or a shrink. The number is big, so that's going to be a stretch. and you would say by 3. And then this last one, we're adding inside. Inside means horizontal, so it's a horizontal. And then we're adding something, so it's a horizontal shift. Inside's always backwards, so even though +2 means we're increasing it, we're actually going to the left side 1. Okay, this one, again, I showed you in class, but I'm not sure if online people or absent people were okay with it. This is a logarithmic function. I forgot to show you this type. It doesn't matter. You'll learn about that in the next unit. But this right here, ln, just means log with a base of e. That means nothing to you. But you can also graph that. So let's look at what the graph looks like over here. So it was -3. No, I can't remember. Nope, that was the previous one. Negative. Now it's under the functions menu. If we want to use the keyboard, functions, miscellaneous. There's your ln. And then you just type the stuff inside. Okay, there's our graph. Isn't it a beautiful graph? Okay, it looks like it's coming along, and then it gets really close to this the y-axis, but it never actually crosses. And we could go up really far and zoom in and you would see, but you should know from looking at the domain and range of the log and the exponential function that they have stopping points. So what I'm going to say is, how far left does this graph go? Looks like it goes forever to the -infinity. And then how about how far right it goes? So I'm going along the x-axis, and then all of a sudden I start shooting up this way, and I don't ever go across to the other side. So it looks like the biggest value that x gets closer to is 0, but it never actually crosses 0, which means that's going to be an open set of parentheses. Okay, the range, if you look at how far it goes down, well, it goes on forever. How far does it go up? It goes on forever. So our range is -infinity to infinity. All right, x-intercept. Let me throw this graph up here for you. Looks like the x-intercept is at -0.5. So let's say, this is what takes up so much time. I want to count by 1 so that I can see the graph a little bit easier. That's negatives. 1, 2. Okay, back to graphing. So at -0.5, it goes through that point right there. So there's your x-intercept, -0.5 and 0. And then it comes up like this and curves and starts riding along that x-axis, but it never crosses the y-axis. So that would mean there's no y-intercept. All right, end behavior. If we are looking at that graph and I asked you, as x goes to the left, as we travel left on our graph, where are the y values going? Well, it goes on forever, and it goes on down, so it would end up at -infinity. Whoops, this was left, so it was negative. Okay, then the right side says as x approaches. Now I can't say infinity because I don't go that far, right? There's no x values over here that have a graph. It stops at this wall right here. Since x is 0 at that wall, that would just be as x goes to 0, comma. Now, what are the ends of the graph going? Where's the y's going? Well, if I'm getting closer and closer to 0, it looks like this red, the numbers are going up here to forever land on the positive end. So f of x is going to +infinity. Okay, this function, it is neither even nor odd, and you can do that by checking the fold in half, it does not match up, rotate it does not match up, so it's going to be neither. Okay. So as far as increasing or decreasing goes, start at the farthest left you can go on the graph, which is -infinity according to the domain. And I'm chewing. Am I going uphill or downhill? Uphill or downhill? Uphill or downhill? I am always going uphill. So we would say it starts increasing over here where we started at negative infinity, comma, and it goes on all the way to 0 where it's increasing. It doesn't go to negative or to positive infinity because it doesn't cross that. Decreasing, it never decreases. If it never decreases, that means there is no extrema. And then we can look at our picture or graph over here to determine what it is. The original looks like this. So you can see there's three changes. We've got a negative out in front, which means a reflection over the x-axis. But we also have a negative inside, which means we also have a reflection over the y-axis. Okay, then this 2 right here, we're multiplying inside. So inside automatically means I'm going to have something horizontal. Because I'm multiplying, it's either a stretch or a shrink, but we don't call it off of this guy. We look at his reciprocal. So there's his reciprocal. Now, looking at that number, if I multiplied by it, would my numbers get smaller or bigger? Smaller. So that one's going to be a horizontal shrink by 1/2. Okay, now we get down to these solving graphically. We went over this in class, but I want to make sure everybody understands it. We don't need that one anymore. So here's the two sides of the equal sign. One's on the left and one's on the right. This red graph is this big nasty one, and the blue graph is the regular one. I'm going to scoot out, squish in. Let me just change. Okay, now it looks much prettier. So when you're trying to figure out where these two equations, these two expressions are equal to each other, you're looking to find the points on the graph that they both go through. This point right here is a point that they both go through. So at negative 2.062 comma blank, I don't care about the y, I care about the x. So one of my answers is that x equals negative 2.06. Okay, that was this one over here. And then over here, they also cross at that point right there, which is 3.395. So we would say, might as well go out 3 decimal places. 3.395. Okay, and then we would double check and make sure, go out pretty far. If you think of end behavior, you should be pretty sure that that doesn't go any further. That's the only places that they cross. And that's it. That's the solution to that one. Okay, we solved this one in class, but just in case those of you that weren't here or need it, it's talking about revenue. And revenue is when you take the number of items you've sold and multiply them by the price per item. For example, if my computers cost $1,000 and I sold 10, my revenue is 10 times 1,000 or $10,000. Unfortunately, in this case, we're given functions. So here's my n. And then here's my p. Sorry, having a hard time seeing. Okay, so that produces a function. Now the first question simply says, what revenue, total amount of revenue generated in 2010. Now if you read the problem thoroughly, you'll see that right here it says that T is the number of years since 2005. Well, how many years have passed by 2010? 5. So my T is 5. Now, in this case, the quickest way is to actually plug it into a calculator. Boop, boop, boop. Here's the number that I get. But you could also look at the graph for that one. I don't want to take the time because the graph is hard to find, but that's how you would do it. Looks like when I plugged it in, I got 104,800. Okay, now this next question says, what is the maximum amount of revenue generated by the computer store sales?